Which among the following is an incorrect statement? The first statement is the reaction taking place in one step is called elementary reaction. Yes, this is the correct statement. So I'll just mark here correct. Further, order of a reaction is an experimental quantity. This is also true. Order of a particular reaction is an experimental quantity. Then we have order as well as molecularity of a reaction can be non-integer. In this case, this is the incorrect statement because if we talk about order, it can be non-integer, but in case of molecularity, we cannot say it should be whole number. It cannot be non-integer. So this statement is wrong. Further, for a complex reaction, rate of reaction is given by the slowest step of the reaction. Yes, it is a fact even. So this is also correct. Which statement is wrong? Statement 3 that's given here is the wrong statement. That's why you should choose it. Further, question number 52. Mass percentage of urea in 0.5 molar aqueous solution of urea is. This is the question in which you have the molality. And what is that? Molality is equal to moles of urea or the solute divided by mass of solvent. What is the solvent here? That is water, and it should be taken in kg. Now, molality is 0.5 molar. And let's assume that the mass you are taking here is 1 kg. So, the moles of urea would be 0.5 mole. So, these are the moles here. Now, with the help of this, we have to find out the mass percentage. So, mass percentage of urea would be equal to the mass of urea taken. You have 0.5 mole. What would be the mass of urea? That would be equal to its mole multiplied by the molar mass of urea. What's the formula for the urea? Urea is NH2 whole twice CO. And its molar mass is 60 gram per mole. So if you multiply 60 here, it would becomes 30. So this is a 30 gram, which is the mass of urea. So mass percentage is equals to mass of urea 30 gram divided by the total mass of the solution. We know that we have assumed that 1 kg of solvent you have taken. So 1000 I am taking here as the mass of solvent plus 30 is the mass of solute into 100. So this value would be 3000 divided by 1030 or 300 by 103. So this value would be approximately equal to 2.9%. And yes, the correct answer is option 2. Now after this, let's take next question. Question number 53. The vapor pressure of two liquids A and B are 100 and 150 torr respectively. It means two pure liquids A and B are there. They have their vapor pressures 100 and 150 torr respectively. The vapor pressure of the solution obtained by mixing 3 moles of A and 2 moles of B will be. It means you are just going to prepare a solution and you want to find out the vapor pressure of that solution. Let's assume that vapor pressure of that solution is PS, and that would be equal to the vapor pressure of pure A into mole fraction of A plus vapor pressure of pure B into the mole fraction of B also. This is based on Raoult's law, and let's find out this vapor pressure of solvent. This PA naught is already given, it is 100. What is its amount? It's 3 moles you are taking. So this 3 moles divided by the total number of moles. Basically, we just want to find out the mole fraction. So that would be moles of that particular substance divided by the total moles of the substances present in the solution. So there are two substances. One is A and other is B. Moles of A 3 plus moles of B 2. So it would be added to PB naught. That PB naught is 150. Would be multiplied by 2 divided by 3 plus 2, that is 5. This would be 300 by 5 plus 300 by 5, and if you solve this, it would be 600 by 5, and this value would be 120 torr. Where this value is given? This value is given in option 2 and I'll choose it as the correct answer. Now, after this, let's take question number 54. Question number 54, it states the quantity of electricity in Faraday required to completely reduce 0.2 mole of permanganate ion to Mn2 positive ions is. In this case, you are just changing MnO4 negative ions in Mn2 positive ion. If you look at these two species, you will find out that oxidation number of Mn is 7 here, while here it is +2. So what would be the N factor? The change in oxidation number is 5. That's why this N factor is 5 here. And on the basis of this equation, you can directly see that for 1 mole of permanganate ion, how many Faraday of electricity you need? 5, because N factor is 5. So 5 Faraday you need. Electricity you need. Now you have only 0.2 mole of permanganate ion. Then definitely the Faraday of electricity would be 5 into 0.2. It means 1 Faraday you need. And that's why that option is given in option 1. So the answer for this question is option 1 also. Now after this, question number 55. If a first order reaction is 50% completed in 4 hours, then the time required for 90% completion of the reaction will be. It means the thing that's given here is that this is the first order reaction, the first thing, and in 50% completion it takes 4 hours. So very clear hint is given that T half for this reaction is 4 hours. Now we know that T half for a particular reaction is equal to 0.693 divided by K, and we are talking about the first order reaction for which it is true. Now we know that this is the formula that we should take here, and on the basis of this we can find out the K value also. This K value would be equal to 0.693 by 4 per hour. This is the K value. Now they ask you to find out the time required for the completion of 90% reaction. So the formula that you will use here is time required here would be equal to 2.303 divided by K. What's the value of K? I'm directly writing here the value of K. 0.693 divided by 4. This is the value log A upon A minus X. A is 100 here. We are just assuming that 100% completion, and A minus X is 100 minus 90. X is 90 that we have taken here. So this value, on solving, you will find out that the T value is equal to 13.29 hour. If you solve this, you will find out the value. And this is given in option 1. And this is my answer also. Now, after this, let's take question number 56.